AP Statistics, what is up? It's Chapter 2 review. Hope you're having a good night. I'm going to actually head over here just for a second. The reason why I'm actually not quite 100% up, set up yet. I forgot. Hold on just a second. I think I've got another thing coming through. There we go. I'm going to pause that bad boy. Hope you're having a good night tonight. We are going to get into Chapter 2 review and get after it today. I'm going to get in my big comfy couch over here, and we're going to go through some questions. So here's the idea. Here's what we're going to do to start this off, okay? Something a little different. I want you to go on to Mentimeter. Here, let me kind of pull this up here. Let me see if I've got this. It's on my other side. Let me get this part. There we are. I'm going to share my screen over here. And I'm going to have you actually share. Yeah, I'm making sure this one's mine here. Let's see if I've got. You see that? Okay, perfect. Okay, you should see Coach J in some sort of weird garb there. You see that there? Okay. So you're going to go to menti.com, and you're going to use the code 42255. And literally for the first, I'm just going to say about 7 minutes as people start rolling in. I'm going to give some time just to kind of dissect some of these multiple choice. I think there's 5 multiple choice questions. And there's also one question that says, what is one area that you need some help with in preparing for Chapter 2? So we're going to be able to just look at that there for just a second there. And I'm actually going to see, can I present this? Yeah, perfect. Okay. And it should be... Oh, yes, I've got hearts coming out, which means that people are showing up. And so I just asked that if you could just take just a second to go through that. And by the way, if you need some help with if you have some problems, you can't go through the YouTube help on the right side over here, feel free to text me any questions you've got. You can go through Remind 101 or through my number 770-757-2240 and get some help there. So you're going to just simply go through these questions. As you answer these, you should be able to go straight through them, and should be good. So I'm going to hopefully allow different items to just kind of pop up here. I think it should be audience paced, meaning that you could go at your own pace. If it is not, I need to switch that, so I just want to make sure. Perfect. I'll let these come up. I think that's true. Pull this up here. Sorry. Perfect. I just want to make sure that my presentations are. This presentation specifically was audience based. I think it was. Perfect. Yeah, I think it is. Okay, perfect. I think it is. If not, let me know. Perfect. Hey, would someone mind putting in the group me real quick, the link? That'd be awesome. I've got, the only reason why I'm doing it on Remind, usually I have no problem doing the other way. I've had a lot of people who are not signed up through that yet, and I want to make sure I hit everyone. So, let's see. Let's see. Post a photo. Perfect. If y'all could get that link up. And again, I'm just holding off for just a second. I think. Okay, perfect. I think this is audience paced. So feel free, throw some stuff up here. And I'm just going to kind of talk through a lot of these topics here and then go through some of these multiple choice. If you have specific multiple choice questions, I will go over those as well. And perfect. Click the link that says. Let's see if I can. Okay, let's see here. See, I'm going to turn that off for just a second. You know, I wonder if it'd be easier if I just put that link right at the top. Perfect. While y'all are doing that, I want to post this on top. Again, I'm going to come back to these. Hopefully, again, if you just joined us, make sure you click on this link with this code and be able to access that there. Oh, that's actually a good idea there, Kristen. Yeah, let me see. Let's do this because there's got to be a way. Here, let me send this link. All right, hold up. Hopefully, you could still see all that mess. Yeah, I got an idea. Sorry, y'all. I need to get a better system, and I'm going to try to do better on that next time. That group me, I think, would be better, to be honest, if I could somehow. Here we go. Awesome. I think this will work. Click on that link. If you're joining late to the party, that's all right. I'm going to give it another about a couple minutes here to kind of make sure everyone's squared away before we kind of hop into all the mess here. And I see a lot of good stuff here. You need to answer with normal CDF and inverse norm. How to tell if a density curve is normal without the picture. Ooh, yeah, that's a good one. Z-score with table A. I need to get a table A up is what I need. So that way I can take a look at that together. It's a good idea. Good thoughts, y'all. I love this. I love it. I'm going to get up table A. I know you're seeing my screen. I'm going to come back. Table A, AP statistics. Let's work on that right there. Good. I'm going to get this underway. Again, hopefully, if you're just joining us, you kind of see we're just going to take some time answering those questions. And here's this isn't kind of FRQs here, but this pulls up the Z-score table A. So we're going to come back to that. Good. We got that there. Good. Okay. So coming back here, I see a lot of good stuff. See a lot of good stuff on the multiple choice. Let me get plugged in with my writing pad as y'all come join. And again, I'll take this time to just go through these ones here. And again, if you do have questions, throw them out there and we'll rock and roll. Cool. All right. Let me give you a couple more minutes to kind of think over topics, answer some of the multiple choice. We'll come back together. Hey, by the way, I need some feedback on this. If you like the format that we're going to do today, the way that we start this lesson by kind of getting a lot of topics and then going after it, I'm doing it a little bit different. I'm just trying to see if this would work better. And it's not completely different. But if you like it, tell me. Okay? Tell me. If you liked it better the previous way, tell me. Because, again, I love feedback. I just want to make it better by y'all. And so let me know. Okay? All right. Give you a couple minutes. We'll come right back. Go right ahead. Bum, 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 bum. All right, we are about ready to begin the official study session. I'm plugging in the tablet. We're going to be underway. I'm going to go over these topics one at a time and then go through some of these multiple choice questions if we need to. And we'll kind of touch base on that as we go forward. I think what I want to do is, because people are rolling in, still kind of answering, I'm going to start at the top. Someone said everything. Well, hopefully this is a good start. If you put that, hopefully it's a good start here. And we'll rock and roll off that. One of the things I want to make sure I mention to you, if you're in my Thursday help session, I will not be there on Thursday morning. I'm going to try to get someone to hopefully fill that spot. But just so you're aware of that, again, rely heavily on this help session that we're about ready to do. And then if you need some real help, come in tomorrow morning and we'll address that accordingly. Okay? Cool. Well, let's begin. I'm going to take off this screen here. I'm still going to be able to see it, but this will hopefully allow me to, hey, what's up, y'all? Will allow me to see some stuff here, and we can just kind of begin with the review session at this point, okay? And we're just going to start with some topics, and I'm just going to go free-for-all, kind of right in here. And we'll go from there, all right? All right, we're going to start right at the beginning as far as the questions go. One thing to remember is, man, stay up on top of this. So if you've got some questions, just pick away at it, all right? Pick away one at a time and go from there. All right, the first one is how to tell if a density curve is normal without the picture. Okay, so today we kind of looked at this data, right, that was listed, and within the data that was listed, there were a bunch of test scores, right? The test scores all across and all that, okay? Now, as we look at this, there's multiple ways that we could tell whether this data is approximately normal or not. The first of which is actually graphing it, okay? We can actually graph this thing. So we can see after graphing it whether the graph looks like it's approximately normal, right? So if it looks something like this, if it was like a dot plot that looks something like this, right? This obviously would not be approximately normal. But if we looked at the pattern, whether we did a dot plot or a histogram, a box and whisker would be a little bit tougher, but we could still see kind of the overall shape with the trend that's there. The question is does it look normal? Okay, does it look approximately normal? And that's the key. It doesn't have to be exact, but does it look approximately normal? The second question that we could also use, and by the way, all of these are sufficient and kind of wrap around each other, so just a heads up on that. One thing, too, is this 68, 95, 99.7% graph. What this means is that 68% of the data falls within one standard deviation of the mean, right? And we're looking if it's close to 68%, not exact, right? So if we took our mean, let's just pretend that I take this plot here, right? If I took the mean, whatever the mean is, and I added one SD to the outside, right? And that's a little far, but you kind of get the idea right here. And then I subtracted one SD, standard deviation. This percentage of the data between one standard deviation to the left and right should be 68%. Two standard deviations, we remember, should be 2 standard deviations of the mean is 95. And 99.7 is 3 standard deviations from the mean, okay? Cool. So each of these allow us to see, okay, well, 95% or close to 95% is within 2 standard deviations. We could approximate this as normal. Again, approximate, it's very hard to have something that's exactly normal. I don't know if that might even be impossible. It's maybe not possible, but pretty close. So traditionally, we're looking at something that's pretty close here. The third way that we could identify whether it's approximately normal is if the mean equals the median. We remember that because if we have something that is symmetric and the mean equals the median, then we could state that this is at least symmetric, right? At least symmetric. Now, we got to be careful on this one because if I put something like this is symmetric, right? The mean and median would be equal to this. However, the question that I would ask you is this approximately normal? Well, the answer is no. It's not approximately normal. It's symmetric, but not approximately normal. And so again, that would be a way that we could show it as well. The last way that we have identified was, if you're in my third period class today, you know I messed up on this and messed up on it really bad because I couldn't see it for some reason. But the fourth way that we kind of looked at today was this idea of if we plotted the z-scores to the context of what we were talking about. Today we were talking about test scores instead of CO2. And if we remembered that if the data fell more, there's less data points on this side than on this side. And so as we looked at it, since there's more data points over here, we would say that this thing would be skewed to the right. Because as we look at this, we scroll to the right side, we notice that there's less data points as we go further and further. But one thing that we would note is if this was approximately normal, we would see this more as a linear pattern than kind of like this curve pattern that you see here. So if I were to see something that looked, again, this is the z-scores, right, of 0, 1, and -1, and it should go to 2, -2, and 3, -3. But if these were the z-scores plotted with the context down below, if I had a plot that kind of looked like this, that followed approximately fairly linear pattern, we would say that it's approximately normal. If it doesn't kind of go towards that, if it's kind of curved or has a shape that does not look like it's a linear pattern, we would state that we cannot say that it's approximately normal, since our expected z-score table or scatter plot, actually I think the official word is normal probability plot, since that was not fairly normal, we state that it cannot, we would not approximate this as normal here. So again, fairly linear, that's the key here, is fairly linear would equal approximately normal. Cool? Awesome. Hopefully this is helping. This is way different than what I've done in the past. Usually we go over problems, but I think I'm just going to go over concepts, and if we need to go over some problems, we can, but I'm going to leave that up to y'all kind of looking at. Number 2, one person says standard deviations, the percentages, I don't know what that means. Okay, so what that means here is if I were to graph this, and this graph, let's say it's approximately normal here, and we say that the mean is a 75 on the last test, and the standard deviation was 10. What this means is if I started at the mean and added 1 standard deviation, as well as subtracted by 1 standard deviation, the distance from here to here, that'd be 68% of the data. Meaning 68% of the data, if it is approximately normal, would fall between 65 and 85. Now, if I subtracted, again, 1 standard deviation, that would be 55, and that would also be 95 if I added it. So between 2 standard deviations, we would state that this produces 95% of the data. And then finally, one more, there'd be like 45 and 105. And between these two, this would incorporate 99.7% of the data points. So it just is a way that if it's approximately normal or bell-shaped, we would expect that it would follow something close or around that, right? If it's like 2 or 3 percentages off, I'd still say that we could approximate this as normal if it followed that general pattern of symmetry and that bell shape that's there, okay? One thing, too, to remember is if I came in and I was to find the z-score of 75, the z-score of 75 would be 0, right? That makes sense because it's 0 standard deviations away from the mean. 85 would have a z-score of +1. 95 would have a z-score of +2. And then +3. You would have -1 on 65, -2 on 55, and -3 on 45. Now, one thing to remember on this, and I think this is key, is if I were to say what percentage of the data falls to the left of 65, well, I know if this is 68, that means that if I divided the rest by, or if we subtracted from 100, we would say that from here and here would be 32%, because added to 68 would produce 100%. So that means here would be 16%, here would be 16%. And we would say then that the percentile of a 65 would actually be 0.16, or the 16th percentile. Okay, that's where we get, again, we use z-scores in this context to find the percentile of approximately normal graphs. It's huge for when we talk about things like height, things like weight, things like grades. And when you hear percentile, that's where it comes from. It's the amount of values that are less than that given value. So it's the percent of values that are less than 65 in this context, okay? So, and you would put, you know, whatever it could be, grades or whatever, make sure you put context within this, okay? Now the problem becomes, and this is where a lot of questions I think stemmed from, is if I get something that, if I ask, hey, what is the percentile of a 60? Well, notice it isn't on a one of the levels that we know of, the 68, 95, 99.7 rule. So because of that, we have to figure out what the percentile of 60 is by finding what the area of the orange is. Would everyone agree with that? If you agree, I want you to yell out right now that you agree in your house. Go. Very good. I'm glad I hear a lot of you. Lindsay, I heard you there. Yes, so what we're trying to do is find what that area is. And when I do that, I can't use this rule. Therefore, now hopefully you bring it over here. You kind of see the stem off on this. That's when I use my z-score table of value minus my mean divided by my standard deviation, okay? Now, what is my value? My value is 60, okay? So I'm going to plug in, minus my mean, which is 75, and divided by 10. So when I do this, I get negative 15 over 10, which is negative 1.5 is my z-score. What is z-score? Yes, I hear you, Emily. The amount of standard deviations below, in this case, below the mean because it's the left side. If it was positive, it would be more to the right side and would be a value that's shaded to the right. So this is where we come to our z-score table, okay? All right, let me see here. Hey, what's up, y'all? I'm going to come over here. Y'all are getting some good questions in. And let's see here. Okay. All right, so this is where we bring in the z-score table. Okay, let me see if I can find this here. All right, perfect. So when I go to our standard deviation of negative 1.5, remember that it's anything shaded to the left side. So if in the context of the problem, we were looking for the values that are greater than or percent that's greater than, just know you have to subtract by 100% to get that there. But here we'll go to negative 1.50, which has a percentile of 0.0668. So that's why we use a z-score table. I'm going to minimize that just so you can kind of see that there and bring up our table there. That's why we use this z-score table A when we don't know, when it doesn't fall exactly on a standard deviation. That's why we have to use that table A to find the information that's there. And so we would say, I think it was 0.0668. So we would say 6.68% of the data falls to the left of 60. And you would write the context of the problem for all AP statistics students or whatever that would be in that context. But you see how the green over here corresponds to values for the 68, 95, and 99.7. And the orange corresponds to what I would do if I was finding the percentile of something that didn't fall on an exact standard deviation value if I added and subtracted there. One other thing, wow, we have a lot within this one, and I apologize. We're kind of hitting a lot. There's another way that we could find what this orange area is. We could obviously draw this, right? Make sure you have the graph and the notation is another thing. You could also do normal CDF. But when you do normal CDF, make sure you put parentheses. This should keep going across. But this would be lower, comma upper, comma mean, comma standard deviation. So what does that mean? Well, that means that if I were to plug this in, normal CDF, the lower bound would be a large negative number. I just put negative 9999, okay? The upper would be the largest number. In this case, it would be the 60 value we're looking at. the mean would be 75, and the standard deviation was 10. Make sure that you include this in place of the work for where the orange is here, okay? So that could replace it. Again, what is normal CDF used for? Normal CDF is used for finding area inside a normal distribution, okay? Should make sense, right? Because it's normal CDF, right? Normal cumulative distribution function, I think is what it stands for. But normal CDF is when we find the area inside the normal distribution that's there, okay? Cool. So you could replace that with the work in orange, all right? Cool. I'm going to pause. I'm going to make sure that I'm not like, sometimes I get going, and I want to make sure that if there are any questions, we can kind of address those and go through those real quick as it relates to these specific things. Oh, man, lots of stuff. Coach Jay's in the house. What's up? Yeah, that looks nothing like you. Oh, well, that's great. Thank you. Hi. Oh, someone said the Menti's not working. I hope it is. If you want to throw questions out here, that's fine. Yes, this live thing is Gucci, Eric. This is awesome. Wow. The game better than all the other teachers go. Well, thank you, Eric. Appreciate you. You know, we show up. You know what I mean? We show up. There's the code. Good. I'm just going through all these comments. Coach Genius. Wow. Hey, that's saying something. Thank you, Lindsay. Appreciate you. Are we only allowed? Sorry, no glasses tonight. Sorry, Ryan. I'll wear them tomorrow. Is that cool? I'll wear them tomorrow. If you want to submit more answers, I think you can maybe at least put them here. Number one on the review, yeah, I can do that. Is writing the thing required to get full context points? Yeah. Good question, Jaden. So if I was to do the, I'm guessing you're talking about the normal distribution, but I'm not 100% sure. Oh, man, I'm cracking up. I'm going through all the comments because I got all of them at one time. Yes, Emily's got it. Emily's showing up. I love it. I love it. I am confusion. Oh, Rita, I'm so sorry. Where are we confused? If you want to, just throw a little comment in there. Yeah, Jaden, so technically, I've been having y'all write that notation down, the N parentheses 75 comma 10 thing. Technically, you don't have to write it down, but I will always like you to write it down just so you're not confused with what the mean and standard deviation is. Technically, you don't have to do that part. You do have to do a graph. You have to shade, and you have to show work and then put it in context at least once within there, and then obviously put the answer down, but you don't have to necessarily put the notation there. Kristen, good question. The negative 99999 thing is you could technically, you only have to do like negative 999, just a negative large number to show that, because we don't have an infinity button. It just shows that it goes towards the left side. That's there. Yeah, Lindsay, that's a good question about the Z-score in terms of the notation. Yeah, you don't have to put the notation. It's not necessary. Kristen, did I clear up that normal CDF? I got your comment, but I didn't know if it was later or before. If I didn't, just put a little comment there that just says, Coach, could you go back over that? Yeah, good job. Yeah, Sarah, good question. I'm going to look at this normal CDF. I think that's one thing that I want to continue to work on. Orange part on the positive side. How would we plug into CDF? Yeah, that's a good one. I'm confused on where you get the value for the Z equals value minus mean. Okay, well, the Z that I used, right? And I think y'all are still viewing my chart here. Okay, I'm looking at the comments, so that's why I was there. Perfect. So one thing, y'all are awesome. Y'all have great questions. One thing that we can look at here is we were shading this part, right? The orange part, which was to the left of the mean. And what we were saying is how did we get the values that were down here in orange? Well, the value that we found, and I just dreamt this up, okay? So I was just saying if we got a 60, what would be the percentile? The value for this formula we put in as 60, right? 75 would be the mean, And that's where I got that there. And 10 would be the standard deviation. Now, once I plug that in, I would get a z-score of negative 1.5. And as Emily helped us with, it helps us by identifying the amount of standard deviations, in this case, to the left of the mean because it's negative, right? So what we then get is once we go to the table A, we recognize that 6.68 is the percent. And therefore, the percentage of values that are to the left of the mean produced would be 6.68% of the data. So this comes from the table A, all right? As I look for what percentage of z-score, or like when I look at this z-score here, it corresponds to this percentage of the data, okay? Does that make sense? I'm hoping I'm making sense here. Y'all's questions are so good, and I want to make sure I get through them, okay? If I don't get through all of them, man, y'all are rocking so much. We have so many questions to go through. We can go through these as well. I'm kind of being sporadic here. The proportion, number 21, okay. Is the upper score normalcy always the same value for z-scores? Upper score normalcy. Not necessarily. It's a good question, Ryan. So in this context, I think sometimes when we do the lower and upper, we confuse it a little bit too much. If I was to say in this white area that I'm shading, what is the lower? The lower value would be negative infinity, right? But we don't have that button because it just keeps going, right? Keeps going. And it gets smaller and smaller. So we just put a negative 9999 as my lower value that is shaded. My upper value would be what it comes to. In this case, it would be 60, okay? Someone asked another question about, well, what if I have this normal CDF graph right here? And let's say it's in the same context and we have a 75 as the average and 85 here and 65 here. And I want to find out what would be the percentage of values greater than 90, okay? Let's try this one. So if I was greater than 90, I'm going to come here, I'm going to stick 90 here, and I'm going to shade the part that's to the right of 90. Now, again, a couple things to note. This is step one. I would like for you to put the notation, but it's not required, 75, 10. I then have two choices. Now, within these two choices, I can go with my z-score and do my value minus my mean divided by my standard deviation, and I'm just going to plug in. So my z-score equals my value. In this case, it's 90, right? The value I have. Minus my mean is 75, and divided by my standard deviation, which would be 10. So this would then produce 25 over 10, or a z-score of 2.5, positive 2.5. So then what I would do is I would go to table A. All right, I'm going to do this a little quicker here. If you need some help with this, I'd love to look at this more tomorrow with you because I want to keep kind of moving. But 2.5 would be 0.9938. The reason why that's 0.9389938 is because this percentage only can be utilized in a table A as finding the values that are to the left of whatever I'm trying to look for. So left of 90. So because that's the case, I have to subtract 1 minus this to produce 0.62, right? Sorry. So 1 minus that would produce 0.062. No, I didn't do that right. 0.0062, sorry. Or what I was trying to say is 0.062. Am I messing up here? Oh, I'm sorry. 6.62%. My fault. Subtract from 1 is what I'm saying. So this is the percentage of values that would be to the right of 90. I have to subtract from 1 because table A only takes into account what's to the left of that specific value, or in yellow. So I have to find white, so I do 1 minus that. Now the second way I can do this is, again, by doing normal CDF. I'm going to keep writing it out so that you don't forget. So it's lower, upper, mean, standard deviation, okay? Now again, then I rewrite it again one more time. My lower value, now again, look at what's shaded. Boom, boom, right here, right? The white part. The lowest value of this white part is 90, right? So we say 90, comma, my large value would be like to infinity and beyond, right? So 99999. So we're going to put that there, 99. My mean, 75. and my standard deviation would be 10. Okay. So once I plug this in, I'm going to get something pretty doggone close to 0.62%. And then I just put a little context with it, and whoop, whoop, you got it. You're good to go. Okay. Perfect. Cumulative frequency graph. I don't think you'll have to actually make it. Just know how to interpret it, Brianna. It's a good question. It's a really good question. Let me come back to Mentimeter over here. Z-score table, we did that one. I got a lot of multiple choice questions. Here's the deal. I'm going to try to go through as many as I can there. I do want to hit inverse norm. I'm going to do that one in just a second. Yeah, we went through the percentage of values to the density curve. Normal thing we did today in place of Z-score. I did that one just as long as you know that if it's approximately linear or fairly linear, it's approximately normal. That's the key. Approaching a problem that we need to answer with normal CDF and inverse norm because that confuses me. Yeah, it's a good one. Hopefully normal CDF. We're going to go over inverse norm here in a second. Is Z-code a more reliable way for finding percents in your opinion? I don't know if it's technically probably the calculator is more accurate, precise, whatever you want to say. I would just, well, is that true? No, that's not true. I don't know which one's more precise, but I would say either one of them works if they're close to each other and you show the work. That's what I care about. So either way, not a big deal there. One more thing, and I'm going to get to actual specific problems because I know that would be helpful. Take the same context because I think it's helpful if you see all of them at one time. All right. Again, we got a test scores that are again, approximately normal. We got a mean of 75. Except this time I want to find out what value or test score, okay, is what we're looking for. We're trying to look for the test score, is in the top 40%, okay? So if I was looking for the top 40%, I recognize that the top 50% would be at 75 and to the right. So the top 40% would be the area shaded here. Now, this is much different than what I did before because at this point, what I'm saying is that, okay, this area is 0.4, okay? So the area is 0.4. This value, I'm going to label as X, okay? I don't know what X is. And so I'm trying to go backwards. Think of it inverse norm as I am going backwards. I am doing the opposite of what normal CDF would do, okay? So I've got my graph. I've got my notation. I can now go two ways. Same thing, okay? I could do my Z-score, which is mean. I'm sorry, value minus mean. Sorry, same thing. I don't know why I just did that. Value minus mean divided by my standard deviation. So let's just plug and chug. So the Z-score is a little different than before, and I'll show you in a second. The value we do not know. The mean is 75, and my standard deviation is 10. Now, this part I think is a little bit tougher because as I look at this Z-score here, remember Z-score on my table A only takes to the left of the value. So I'm looking for not 0.4, but where the Z-score would be 0.6. Now, remember, Z-score is not the area inside, right? That's much different. The area inside we use for table A to find what the Z-score is. So let me show you what that means here. What's up, y'all? Good to see you again. Sorry. We're going to go to I'm going to get this table A here. Sorry, for those of you who have questions like other questions, I'm sorry. I just wanted to hit on these major topics, and hopefully this will address other questions as well. Okay, so if you look at where 0.6 would be, 0.6, you're going to look, this is the area to the left of the curve, right? So again, look right here to the left. It's shaded to the left, and you see that in the table. So 0.6 is the area. The area is inside, and it corresponds to Z-score up above. So where's 0.6? Let's see. And you could probably use one of these two, either one. But you would use 0.25. So 0.25 is kind of what we would have here, okay? So again, we're going to go to 0.25. Let's see here. Pull that up. Sorry, I keep having to share my screen all over. There we are. So what we would have now is 0.2. Is it 0.25? Dadgummit. Literally, I just forgot it. I hate when I do that. 0.25. Good. And so we're going to put that in for our z-score. So 0.25, standard deviations to the right of the mean. Make sure it's positive because it's to the right of the mean. We could do this now, solving it by multiplying by 10. Okay, so we get 2.5 equals x minus 75. Add 75 to both sides, add 75, and we get x, or the value, is equal to 77.5 right there. Okay, and that's how I would get that value. I'd float down a little neater and then put it in context that in the top 40% of the test scores, we found that the test score would be 77.5 or above. Okay, step 2 is a little different. Again, inverse norm is where we're headed. This time we do the area because we don't need lower and upper bound now, right? Just the area, the mean, and the standard deviation. Again, I'll plug this in by actually putting in the area of this. Again, it's to the left, so be careful on that. So it'd be 0.6, 75, and 10. And when I do that, I get those values that are there. Whew, that was a lot of concepts. Hopefully that helped you out a little bit. Let's go over some questions here, and then we'll get started. Thanks. Good. Can you explain how to interpret a cumulative relative frequency graph? Is there a question on there? Rita, if there is, could you just take a look at that? That way we can kind of find one on that. When you get two different values and have to standardize them and find the z-scores, then it asks you which is better. Is the better one the higher z-score? Yes. The better one is the higher z-score. So if you compare two z-scores, the higher z-score means that you are in the higher percentile. Great question. Great question. No, if you choose z-score, if you do z-score, you do not have to do normal CDF and vice versa. So just choose one. Just choose one. That's all you need on that one. Good question. So I want to get to some of the multiple choice questions, and I'm going to start above and just kind of roll my way down. Someone said, let's do number 1 on the review. So let's start with that one here. And I'm going to just blow them up as I go through, and I'm guessing they're on this. The question is, I think, is which one's true? So let's look at this first. We have a density curve. The area is 1. Okay. The density curve is normal. Well, that's definitely not true. We can see that here, right? We can see that here. I think, yeah, we're good here. Do this one. Okay. So we would say that the density curve is definitely not normal. So we would say that this would be not D. Is the median is 0.5. So if 0.5 is here, this would be the median value on that. I would say that the median's not here. This would also be skewed to the left, wouldn't it? It'd be skewed left and not right. Okay, I got that mixed up today. I've got it figured out now. Is it symmetric? No, it's not. Is the median larger than 0.5? Yes, it is. Got me? Because the median's going to hang out where most of the data is. The mean, X bar, is what goes towards the where most of the data is. And so that's why number 1 would be an answer of B there. Good question there, Brianna. I'm just going through questions, seeing if you have one. Good. Cool. Y'all have some good questions here. Go over number 30. Let's do number 30. I've got some other questions that were on the Mentimeter that I haven't forgotten about. So if you're like, Coach, I thought you said you were going to go through them. I am. My game plan is just to hit on a couple of these on the YouTube and then kind of come back to that. Okay. All right. This one says a soft drink machine can be regulated so that it discharges an average of question ounces. We don't know what question is. If the ounces of fill are normally distributed, there it is. If they say that, just draw a normal distribution. I'm telling you, you're going to have to use it. With the standard deviation of 0.4, what value should question mark be at so that 98% of, there it is, 98% of 6-ounce cups will not overflow? All right, that's a good one. So a soft drink machine, I got to kind of read this one myself, can be regulated so that discharges an average of question ounces per cup. what value should question be so that 98% of 6 ounces cups will not overflow? Man, that's a good one. So the mean is the question mark, is it not? So we're trying to find the question mark, comma, 0.4. And so as we look at this, what value should question mark be so that 98% of 6 ounce cups will not overflow? Well, this is a good question. What value should question mark be at so that 98% of 6 ounce cups will not overflow? It's a good one, y'all. If you take a look at this one, number 30, I'm looking at how I would attack this. Well, 0.4 is the soft drink machine can be regulated so that it discharges an average of question mark ounces per cup. If the ounces of fill are normally distributed. Okay, so what I would say, this is the average, right? The average is here. We know that, and this down here represents the ounces that's given, right? Ounces that are given. So charge an average per cup. So what we're trying to do is saying, okay, 6 ounces would be over here, right? And it says be set at 98%. So 98% of the data falls to the left, and 6 ounces would be the value that corresponds to that 0.98 area, okay? So if I were to do a z-score equals value minus mean divided by my standard deviation. Let's take a look at this. Let's just check it out. If I were to find the question mark, the value would be 6, okay? My mean is an x because you can put x bar if you want. That's what we're looking for. My standard deviation is 0.4. My z-score is where I would go look for 0.98. So I'm going to come over here and I'm going to say, okay, 0.98. I'm looking for the area, 0.98, 0.98, 0.98-ish. And I got 2.06. 2.06, I think is what I got. Yeah, I got 2.06. So we would set this equal to 2.06. Let's check it out. I want to see if this is right. So 2.06 times 0.4. I'm doing it up here. 2.06 times 0.04. And then I subtract by 6. Again, I'm just solving this equation. If you're like, Coach, what are you doing? Subtract by 6. And I got 5.9176. I would say that that's closest to approximately. Someone do this. If you did that differently, could you just throw that out there? I'm getting stumped on this one as far as my setup, and maybe I'm just going too quick through this one. Inverse norm, make the max 6. Inverse norm. Inverse norm. What'd you put as your mean then, Eric? Well, I tell you what, this is not necessarily the best, maybe the best of answers. But what I would do is just put inverse norm on this. And then when I put my area, put 9.98, comma, my mean. My mean is whatever these values are, right? I would just test these out. And I know it's a bad way of doing this, but it's a multiple choice question. Plug these values in to my mean and then put 0.4 as my standard deviation. And see once I set that up, which value comes closest to 6 ounces. That's how I would attack that. I really would. I mean, I went backwards with it, but for some reason, I think the way that I rounded was a little weird, or maybe the way the question's worded that I'm not 100% understanding what they're asking. I'll tell you what. Oh, is that what I did? 0.04? Did I do that? Let me make sure. Oh, that's right. I did 0.04, and that's where I messed up. Cool. Yeah, there it is. 5.18. Is that it? 30? 30, yeah, 30's A. That's it. I did it right. Everything was good here. But what Eric said was true. You could actually use inverse norm and go backwards. Ryan, thanks for catching me on that because I didn't really – I said it, but I wrote it down right, but I put it in wrong. But if you plug this in, X bar would then give me 5.18, and that would help me out there. Sorry, that's a good one. Good question. Math God, but sorry, sometimes I struggle along with y'all. So I hope that that should be an, I don't know, encouragement, I think. But just that, sometimes you just got to kind of wrestle with it. And if you need to, skip it and always come back to it. All right. All right, let's see. I see a couple other ones here. 30, 21. Okay, Jaden said something about the proportions of the negative 0.75. Let me see how we did on the multiple choice here. Let's see. Cool. Oh man, we messed up on that one just a little bit. Let me do this. Let me pause for a second. Come back to Mentimeter here. Make sure that we're all good. Let me see. Come back here. Maybe we could talk through these. Cool. Sorry, I'm like comfortable now. We're going late. We're going late tonight. I love it. I love it. Y'all are warriors. Y'all are absolute warriors. Keep it up. Okay, so I want to go over these multiple choice ones real quick. I saw that these were kind of tough for us a little bit. Let's see if we can check it out. I picked some of the tougher ones. So if you're like, man, these were tough. Well, that's because I literally chose the toughest ones. I was like, what ones are the hardest? And then I showed it. All right, it says, which of these variables is least likely to have a normal distribution? Annual income for all 150 employees at a local high school. Okay, gotcha. Lengths of 50 newly hatched pythons. Okay. C is heights of 100 white pine trees in a forest. Is least likely. Oh, okay. Least likely. That's the key. Least likely. Okay, so first off, B, lengths of 50 newly hatched pythons. I would say that would be definitely approximately normal because you'll have a mean of what they would be. Some fall on one side, some fall on the other, right? Think of our activity when we, our 3 activities where we rolled the dice and then we threw the coin, and then where we stop the stopwatch. The stopwatch would follow more of what B would be approximately normal. The heights of 100 white pine trees, same thing, still approximately normal. D, amount of soda in 60 cups filled by an automated machine at a fast food restaurant. Yeah, I would say that D also would be approximately normal because sometimes it could fill above, sometimes below, approximately normal. Weights of 200 of the same candy bar in a shipment to a local supermarket. Yeah, same thing here. That would be the same thing here. The annual income for all 150 employees at a local high school. Here's the deal. When you go to high school, and this might be a tough question. When you have incomes, a lot of times that you have an average, but then there's a lot that fall. There's a lot of outliers. There's a lot of people that are either there for a long time or have been. Let me go back. Where A, I think would be the best answer, although I don't necessarily like that question because you have to have some context there. But I just want you to think about what makes a normal distribution and then kind of rock and roll from there. Cool. I think A was the right answer on this one. You would find it. Let me see what the caret was. C was the caret. Oh, yeah. So the proportion of observations from a standard that take value. Oh, hold up. Values larger than negative 0.75 is about. Okay. So larger than negative 0.75. It's one of these two. But if it's larger than, think of a normal distribution, it's to the left of the mean. If it's larger than, make sure you take this value, subtract it from 100 to get what B is. Or hold up, to get what C is. Got me? So the answer should be C. The answer should be C. Because what I would be doing is taking this, subtracting it from 1, because I'm doing, again, the key, values larger than. So when I graph it, I'm graphing everything to the right. You found everything to the left if you answered what the answer A there, okay? This one, are y'all seeing this? Okay, good. The distribution of the heights of students in a large class is roughly normal. The average height is 68 inches and approximately 95% are between 60. Thus, the standard deviation is approximately equal to, yeah, B is correct. Good. Some of you put 2. If you're wondering that, 68 inches is the average height. If you added 2 twice, you'd get 72 to the right and 64 to the left. But that's just a little off because, again, 95% is 2 standard deviations to the right and to the left. So what I would do is I would graph this. Again, test them out. If it's 3 to the right and left, that's what would produce 62 and 74. Check out this one. The mean age is approximately normal with the mean as such, and Barack Obama was 47 when he was inaugurated, which is the 11th percentile of the distribution. Which of the following is closest to the standard deviation of presidents' ages? With a mean. All right, so this one, the 11th percentile would be 0.11 to the left, right? Okay. I would use, again, this is why the z-score formula is important. Use the z-score formula. Okay, you'll find your z-score by, for 11%, you're going to put in 0.11 in for my table A. And when I do that, my 0.11 would be, make sure it's close to, I think this right here, one of these two is fine. So negative 1.22 or 3. And once I plug that in, I then put it into my z-score formula. Sorry, where are you? There I am. And once I do that, I then will put in my mean of 54.6. My value is 47. And the value that is unknown would be my standard deviation. And that's what you would solve for there. So you just solve it like an algebraic equation, kind of like what we did earlier on the number 30 we did earlier there. All right, the 16th percentile of a normal distribution has a value of 25, and the 97.5th percentile has a value of 40. Which of the following is the best estimate of the mean and standard deviation of the variable? I think here we got this, boom, boom. So that one, I would do the z-score. Let me see. I know of how I do it. I just want to make sure before I explain it that if there was an easier way. One thing I would do is I would just try to test them, to be honest. I'd start with 30 or 32.5 and take the standard deviation and add and subtract it. And notice that the 16th percentile, if you went on my normal distribution, 16th percentile would be to the left side over here. And that means that that value would be 25. I would graph it out and do your 68, 95, and 99.7% of the value there. And just test to see which one would work there on that side. 100% of you got E, so I'm guessing we were money on that, and I think you're right because it would be yes. Okay, yes, you're right. Good. And we go from there. I didn't check this one. Yeah, this one was tough here. This one's tough. You're working backwards using your z-score formula, to find that standard deviation that's there. Perfect. Let me look at some of these comments, making sure we're all good. Yeah, I put in the calculator wrong. Perfect. Eric's awesome. Appreciate you. Appreciate y'all for helping. Ryan, thanks for helping me. Number 7. How to find the nth percentile when looking at an approximately normal curve. Approximately normal curve, nth percentile. Lindsay, would you mind if we looked at that tomorrow morning? I just want to make sure that what you're asking is what I'm thinking. So I just want to, I don't think it's going to be a huge question to answer, and so I just want to make sure we're good. Cool. I'm going to do this. I'm going to give it about the 10-minute warning here. And just kind of start winding down. If you, for some reason, I know Grace, you said 29. I want to do that one. 29 and Brianna said 7. So I want to go over 29 and 7. Make sure that we go through those. And I'm fastly fading. Sorry. I'm so tired. I don't know. I think doing these study sessions, they're fun, but man, they wear me out. Going through. All right, let me see. 29. It's right up here. And then 7. Let's look at it. 29 says using the standard normal distribution table, the area under the normal curve corresponds to area. Oh, this is the z-score. Okay, so we're trying to find the area under the curve, right? It's a z-score. So anytime there's a z-score, this is a thing to know. My mean is 0 and my standard deviation is 1. That's what it means to be standardized, okay? All right, so the mean would be 0. My standard deviation is 1. Negative 0.5 is my first value, and 1.2 is my upper value, okay? So what I'm going to do is I'm just going to shade this bad boy, and whoop, 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 whoop. There we are. And we're going to find what that area is. And to do that, we just go to normal, CDF. You don't have to show work here because this is just a multiple choice. The lower value would be negative 0.5. My upper value is 1.2. My mean is 0. My standard deviation is 1. You could take that and go from there. Now, there is a way you could do the z-scores. What you would do is you use your z-score formula. And what you would do is use 1.2 for the upper z-score and negative 0.5 for the lower. And what you would do is take the upper minus the lower because you got to take away that part there. Okay. But this right here would also work for normal CDF, so you could use that one as well. Okay. Are y'all still following me? Good, good, good. I want to make sure you were there. Woo! All right. Number 7, the 5-number summary. Okay, there you are. The 80th percentile was. Okay. Well, we don't know, do we? We really don't know about the exact 80th percentile. We know that the 25th percentile would be at Q1. The median would be 50 percentile. Q3 would be the 75th percentile. And so if it says the 80th, it's somewhere right in here, right? That's because this is from the 75th to 100th percentile or 99th percentile. So as I look at this dot or line right here, I'm looking at what would fall in between. Well, it should be between 76 and 100 based on the information that I know there. Cool. Cool, cool. All right. Gucci, Gucci, Gucci. Sweet, sweet. Man, I tell you what, y'all are rocking. I'll be honest, I'm pumped up. I hope this was helpful. I recognize there's a lot of material for this, and we move at a fast clip, and I get that. I just encourage you, continue to come in for help, show up to these help sessions. The only thing that I would say with this group, y'all rock on the engagement in class and through these help sessions. Sometimes it is beneficial to meet with me one-on-one. I know Brianna, Lindsay, and Jaden have done a great job of that coming in. So keep up the good work. Care about y'all. Love y'all. It's Gucci in here. I'm tired. You're tired. Man, get some sleep. Have some rest, like Coach Meeker and the Chapel crew said. And man, just have a phenomenal night. I'm trying to have a song to go out to. You know, like a pep song, you know, I'm trying to think. If I had one song, it might be this song, I think. Let me see if this kind of. Yes! Just Beat It by Michael Jackson. Have a great night. And study hard. Study hard. Come in tomorrow morning if you do need help. We'll go through some extra questions. See y'all.